Hello and welcome to the continuation of our mathematics series, and as you've known, we are still in the number basis topic. This is going to be our 7th lesson, and this lesson is going to be about hexadecimal numbers, although I should have done it partly with the rest, like the octal numbers, meaning octal base 8, and the binary, but then I just chose to do this one separately so that we explain further, because it's going to need some more explanation compared to the others. Hexadecimal means base 16. Base 16. So, and that's first of all, that's the first thing you need to know, base 16. Second thing you need to know, and I'm sure you've known this, it's the range of numbers it can accommodate is from 0 to 15. So that's what we said earlier on. We said if we're talking about octal bases, meaning base 8, so it's going to, the numbers that base can accommodate are going to be from 0 to 7. So but this one is base 16, so it's going to have from 0 to 15. And then what do we do when we reach 9? So this is how it is. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. As soon as we reach 9, the rest of the numbers to 15, we are not going to write them in numbers, in number form. We are going to write them in letters form. So the next one is going to be A, B, C, D, E, and F. Meaning this one will represent 10. This one will represent 11. This one 12. This one 13, and this one 14, and finally this one 15. So don't be confused when you see questions that say maybe you should convert BD in base 16 to decimal. This is totally normal. So BD to base 16, what you are going to do is, what is B? What does B represent? It represents 11. And then what does D represent? It represents 13. So they say you should convert 1113 in base 16 to decimal, to base 10. Base 10. And you can see that we are writing this one separate from this one, because this one is like saying 1113. Not if we're talking in base, let's say 4 now, you see that we have 1113. But then since it's base 16, what you need to do is try as much as possible to just separate them so that you don't get confused. So that's it. So now we are going to take an example so that you understand better. So this question says, the first one says you should convert 16 BC in base 16 to base 10. 16 BC in base 16 to base 10. Alright. So what we need to do here is, as I had told you earlier, we're going to write down the numbers 1, 6. Then B is what? B is, we said A is 10, B is 11, so 11, and C is 12. C is 12. So that's it. So now what you are going to do is, for this one we have 0, for this one we have 1, for this one, these ones are separate, so 2 and then 3. I hope you understand. We separate, the numbers stay the way they are, the same, 1 and 6, but the letters will be separate. 11 for B and 12 for C. So now on 12 we have 0, on 11 we have 1, on 6 we have 2, on 1 we have 3. So now since we are converting from base 16 to decimal, meaning from base 16 from hexadecimal to decimal, I said whenever we are doing that, what we need to do is to multiply this one times the base we are converting to, times the base we are using, rather times the base we are using. So 1 times 16 raised to power 3, the power. Then we go to the next number. It's going to be 6 times the 6 times 16 raised to power 2 plus 11 times 16 raised to power 1 and plus 12 times 16 raised to power 0. So this is very simple. So now we go to the next step. It's 1 times 16 raised to power 3 is just like saying 16 times 16 times 16. plus this 6 times 16 raised to power 2 is 16 times 16, right? 16 squared is 16 times 16 plus 11 times 16 raised to power 1, which is the same thing as 16, and then plus 12 times 16 raised to power 0. If you can remember, we said any number raised to the power of 0 is 1, so we write down 1. So now what is upon us is to find the calculator, or if you can compute it with our heads, then that's okay, but then it's preferable to find the calculator and just make these computations. So 16 times 16 times 16 is 4096. So we have 4096. Of course, times 1 is the same thing. So 16 times 16 times 16 times 1 is just the same thing as 16 times 16 times 16. Then plus 6 times 16 times 16. Just give me a second to check my calculator. 6 times 16 times 16. The answer is 1536. Plus 11 times 16. 11 times 16 is 176. You can carry along, you can go along with me by using your calculators too to check if I've made any mistakes. Plus 12 times 1 is 12. So now we need to add up everything here. Our answer is 5820. This one is in base 10. So that's it. So when we are converting a number from base 16, as we had done earlier, whatever number we are converting, if it's to base 10, then this is the long multiplication method or long multiplication process we are going to use. But then if you want to also convert from base 10 to base 16, we use the long division method or long division process. So now I hope you understand this one. It's very simple. We separated the letters but then left the numbers the way they are. 1 we put 1 and 6 we put 6, but for the numbers, for the letters rather, we put them separate. B is 11 and C is 12. So when we want to use the power form, we want to put the power on their heads, we write the power for both numbers, for 0 on 1 and 2 and 1 on 1 and 1. But then since these ones are in number form, we write them normal. We write each power for each number. So that's it. Then the second example says we should convert this number to base 16, meaning we should convert it to hexadecimal. So this is also very simple. We said whenever we are converting a number in base 10 to another number or to another base, we use the long division process or long division method. So now we are going to write down, we are going to draw our long line, put the number we are converting to the base we are converting to. So here is it. The base we are converting to is base 16. So now we will say 50 divided by 16. How many times will 16 go into 50? It's going to go 3 times, because 16 times 3 is 48. So it's going to go 3 times. But there will be a remainder. The remainder 2. Then we can go again. 16 into 3 is not possible, so we write down 0. Remainder this 3, that is not possible, so we write it, we bring it down. And since here we have a 0, we say we stop here. So that's it. So we draw our long line from the bottom to the top to show the direction we are using. So 3 and 2 going to be 3 and 2 in base 16. So that's it. So far we've been able to convert base 2, other bases like base 5 and base 4, and then octal to base 10, octal numbers to base 10. And then we've been able to convert those base 10 numbers back to the base 2, base 5, and base 8 we've used. We've also now talked about hexadecimal numbers. We said there are numbers that are in base 16, and then we talked about the range of numbers it can accommodate from 0 to 15, and then we explained the letters which we have to use to represent the numbers that are up to 10. Like 10, we said we were going to represent it with an A. 11, we are going to represent it with a B. 12, we are going to represent it with a C, and so on and so forth till we reach F, which is 15. Alright, so now what we have ahead of us is how do we convert numbers that are not in base 10 to other numbers that are not in base 10. And that's what our next example is going to talk about. We are just going to take one example and then we are closed for conversions in number bases. The next step we go to is going to be about arithmetic, multiplications, additions and subtractions in bases. Alright, so we have an example here that says convert 1101, which is in base 2, to base 5. Alright, so when we are doing this, you can see that there is no base 10 mentioned. And what we've learned so far has been conversions to base 10 and vice versa. Now what we are going to do is we need to convert this number that is in base 2 to base 10 first, and then the answer we get, convert it to base 5. So that's how it's going to be. So we have two conversions at hand. So we said if we are converting a number 1101 in base 2, what we need to do is write down the number 1101 and then write their powers at the top, 0, 1, 2, 3. And then we write 1 times the base we are working with, 2, raised to power 3, plus 1 times the base we are working with, raised to power 2, plus 0 times 2 raised to power 1, plus 1 times 2 raised to power 0. The 2 is from the base, and then the 0 is from, this is 0 is from the power. Alright, so this one is just like saying 1 times 2 raised to power 3. 2 raised to power 3 means 2 in 3 places. 2 times 2 times 2. 2 times 2, 4. 4 times 2 is 8. So 1 times 8 here, plus 1 times 2 squared is 2 times 2. 2 times 2 is 4. Plus 0 times 2. 2 raised to power 1 is 2. Times 0 is 0. Plus 1 times 2. 1 times 2 raised to power 0. 2 raised to power 0 is 1. So here is 1 times 2 raised to power 0 is 1. So 2 raised to power 0 is 1. We said any number that is raised to the power of 0 is equal to 1. So 1 times 8 here is 8, plus 1 times 4 here is 4, plus 0, plus 1 times 1 is 1. So our answer is 8 plus 4 is 12, plus 0 is still 12, plus 1 is 13. So we have 13 in base 10. So we have converted this number to base 10. The next thing we need to do is convert this, what we have now, to base 5 so that we'll get our complete answer. So we said if we are converting a number in base 10 to another base, we do the long division method. So we draw our line and put the 13 here, because this is what we are converting. We are converting 13 to what base? To base 5. So we write the 5 here. So how many times will 5 go into 13? It will go 2 times, and we have a remainder of 3, because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So remove 5 out of it all. 1, 2, 3, 4, 5. Another one. 1, 2, 3, 4, 5. So you can see we have 1, we have 2. Then this one is not up to 5, so we have 1, 2, 3. So it's 2, remainder 3. So we take 5 again. We said we are only going to stop when we have a 0 here on the right hand side. Alright, so 5 into 2 is not possible, so we write a 0. Remainder, this 2, so we write it down 2. So we stop here because we have a 0 here, and draw our line from the bottom to the top to show which direction we are using. So we are using 2, 3. So our answer is 23 in base 5. So that's it. Very, very simple. What you have now in the next video is going to be a quiz consisting of all what we've done so far, and you can just feel free to do them and then submit through the platform.